Solving system of linear equations using the substitution method. The substitution method works best when one equation is solved for a single variable. Here are some steps. Number one, isolate either x or y variable in one of the two equations. Substitute the expression found in step 1 into the other equation. Solve the resulting equation. Substitute the value found in step 3 into either of the original equations. Solve for the remaining variable and write your answer as an ordered pair. All right, let's break this down with example 1. Step 1 is to isolate either x or y. Well, we already have that taken care of. We have y equals 2. We actually have x equals 2 as well. Step 2, we're going to substitute the expression found in step 1 into either of the other equations. I am going to substitute what x equals to into the first equation. So since x is equal to negative y, I'm going to take this x out and plug in what x is equal to. I now have y equals negative 3 times negative y plus 8. I have one equation with one variable, and I will solve for y. Step 3 was to solve the resulting equation, which we did. We now have y equals negative 4. Step 4 is to substitute the value that we found into either of the original equations. So I have y is equal to negative 4. I can plug that into either of the original equations. So I'm going to plug it in to the x equals. So the original equation is x is equal to negative y. So I am now going to plug in that negative 4 for y. So x is equal to a negative 4. So x is equal to 4. Step 5 is write your answer as an ordered pair. X is equal to 4 and y is equal to negative 4. Again, substitution means you solve for a variable and you take it out and you substitute in what it equals in that equation. All right, let's look at example number 2. I would recommend either solving the first equation or the second equation for y because both of them have a coefficient of 1. I wouldn't solve for x because it's probably going to lead us to some fractions in one of the equations. And it doesn't matter which one you want to solve for. I'm just going to solve the second equation for y. Y is equal to 4x plus 8. I'm going to take the y out of the first equation and substitute what y equals in. My new equation, 2x plus 4x plus 8 equals negative 4. Now, I only put the parentheses around the 4x plus 8 to help you see that I've taken the y value or the y variable out and I've substituted in what y is equal to. I would also recommend you put the parentheses in just in case it was 2x minus y. You know, watch your signs there. But for the plus, I'm just going to take those parentheses off, combine like terms and solve for x. x is equal to -2. Now I can substitute in -2 for x in either of the original equations. And I'm going to select the first equation. So I wrote it there so we can see what I'm doing. Plug in -2. Solve for y. Yeah, I forgot my negative. Here it is. Don't panic. So my ordered pair is at -2, 0. Example 3. In order to not have fractions, I'm going to solve the second equation for x. It is the only variable that has a coefficient of 1. So I'm going to solve for x by subtracting 2y from both sides. Now I'm going to substitute in -2y plus 8 in the first equation for x. So this x is coming out, and I'm plugging in -2y plus 8. I'm going to distribute, combine like terms, and solve for y. So y is equal to 3. I'm going to substitute 3 in for y in one of the original equations. I'm going to use the second equation. X is equal to 2. Write your answer as an ordered pair. X is 2, y is 3. Example 4. I'm going to solve the first equation for y. So I'm going to add x to both sides. I'm going to substitute in x plus 2 in the second equation for y. Distribute, combine like terms, and solve for x. Substitute -1 in for x in one of the original equations. I'm going to pick the first one. So I have y minus -1 is equal to 2. That's y plus 1 equals 2. So y equals 1. The intersection point is at -1, 1. Example 5. I'm going to solve the first equation for y, because that's the only one that has a 1 in front of it. So I'm going to add the 1/2 x to both sides. I'm not going to let fractions scare me. And then I'm going to substitute in 1/2 x plus 2 for y in the second equation. 2x minus 4 times 1/2 x plus 2 equals 12. Distribute the -4, combine like terms, and solve. Clearly, -8 does not equal 12. So this is false. Well, what does this mean in terms of our answers? Well, our answer is no solution. And what does that mean if we have no solution? Well, in terms of our graph, it meant we had parallel lines, same slope, different y-intercept. So when are we going to get a no solution for our answer? Well, what happens is when the variable is eliminated, and the result is false. All right, so let's take a look at the second equation. This is just extra added bonus material here. If we have 2x minus 4y is equal to 12, and we want to solve this for y, we have y equals 1/2 x minus 3. We have the same slope of 1/2. We have different y-intercepts, -2 and -3. So it all fits together. as to why we have no solution. How it looks on a graph or two parallel lines. How it looks doing algebra is the variable is eliminated and the result is false. Example 6. Well, we already have one equation solved for y. So we're going to take x plus 3 and substitute it in the first one. This is where you definitely need the parenthesis because you must distribute the negative. So we have x minus 3 equals negative 3. Simplify, negative 3 is equal to negative 3. We could stop there, but we're going to go one step further. If we add 3 to both sides, we're going to have 0 equals 0. But the idea is the variable is eliminated and the result is true. Well, what does that mean? Well, when the variable is eliminated, and the result is true, then we have infinite many solutions. Which means the two lines are the same. And I can prove this to you again. Here's some bonus material. Is if we solve the first equation for y, if we put this in slope-intercept form, I can subtract x from both sides and divide everything by -1. And we can see that the two equations are the same, making them the same line. All right, let's try number 7. To avoid fractions, I'm going to solve the first equation for y. So I'm going to subtract 5x from both sides. And then divide everything by -1. I'm going to substitute 5x minus 7 in for y in the second equation. Well, for x, we get x equals 2. Substitute 2 in for x in one of the original equations. I'm going to select the first one. I don't know why I just put a 1 there. Clearly it's 3. So the answer would be the ordered pair 2, 3. And again, you can always substitute your ordered pair into both of the equations, and they will be true if your ordered pair is indeed the solution. All right, example 8. We have a couple choices here. You can solve the first equation for y, which probably is a good idea, or solve the first equation for x. I could solve for y, but I see some negatives. So I'm going to solve the first equation for x by adding y to both sides. And then I'm going to substitute it in the second equation. So I have 6 times y plus 4 minus 6y equals 24. So I have one equation with one variable. I'm going to distribute and combine like terms. So the variable has been eliminated and the result is true. So that means I have infinite many solutions. And I could subtract 24 from both sides. That would give me the 0 equals 0. You might see that in your homework. I could also justify this. I could also get a little bonus material here, is if I looked at the second equation and I simply divided it all by 6, I have x minus y is equal to 4, and I can see that that's the same as the first equation. All right, example 9. I would solve the second equation for x because it has a coefficient of 1, so just subtract 2y from both sides. Substitute in negative 2y for x in the first equation. Divide both sides by negative 20, and y is equal to negative 1/10. It is okay to get fractions for answers, which is why this would not be a good one to solve by graphing, because we could not graph accurately to get an answer of negative 1/10 for our y value. So now let's plug in negative 1/10 for y. I'm going to use the second equation. X is equal to a positive 1/5. So my ordered pair would be 1/5 and negative 1/10. And number 10, you might notice that both equations are solved for y. If both equations are solved for the same variable, you can set them equal to each other. So they're both equal to y. So let's just set 4x minus 10 equal to negative 3x plus 4. you can think of it as I'm substituting in for y. I'm going to add 3x to both sides. Add 10 to both sides. And divide both sides by 7. X is equal to 2. Plug in x equals 2 into one of the originals. I'm going to select the second equation. So y is equal to 8 minus 10. And y is equal to 2. Negative 2. So my answer is the ordered pair 2, negative 2. That concludes the video on substitution.